To begin with the second point, let us say that no definite characteristic distinguishes the plant from the animal. Attempts to define the two kingdoms strictly have always come to naught. There is not a single property of vegetable life that is not found in some degree in certain animals, not a single characteristic feature of the animal that has not been seen in certain species or at certain moments in the vegetable world. Naturally, therefore, biologists enamored of clean-cut concepts have regarded the distinction between the two kingdoms as artificial. They would be right if definition in this case must be made, as in the mathematical and physical sciences, according to certain statical attributes, which belong to the object defined and are not found in any other. Very different, in our opinion, is the kind of definition which befits the sciences of life. There is no manifestation of life which does not contain, in a rudimentary state, either latent or potential, the essential characters of most other manifestations. The difference is in the proportions. But this very difference of proportion will suffice to define the group, if we can establish that it is not accidental, and that the group as it evolves tends more and more to emphasize these particular characters. In a word, the group must not be defined by the possession of certain characters, but by its tendency to emphasize them. From this point of view, taking tendencies rather than states into account, we find that vegetables and animals may be precisely defined and distinguished, and that they correspond to two divergent developments of life. The divergence is shown, first, in the method of alimentation. We know that the vegetable derives directly from the air and water and soil the elements necessary to maintain life, especially carbon and nitrogen, which it takes in mineral form. The animal, on the contrary, cannot assimilate these elements unless they have already been fixed for it in organic substances by plants, or by animals which directly or indirectly owe them to plants, so that ultimately the vegetable nourishes the animal. True, this law allows of many exceptions among vegetables. We do not hesitate to class amongst vegetables the Drosera, the Dionaea, the Pinguicula, which are insectivorous plants. On the other hand, the fungi, which occupy so considerable a place in the vegetable world, feed like animals. Whether they are ferments, saprophytes, or parasites, it is to already formed organic substances that they owe their nourishment. It is, therefore, impossible to draw from this difference any static definition, such as would automatically settle in any particular case the question whether we are dealing with a plant or an animal. But the difference may provide the beginning of a dynamic definition of the two kingdoms, in that it marks the two divergent directions in which vegetables and animals have taken their course. It is a remarkable fact that the fungi, which nature has spread all over the earth in such extraordinary profusion, have not been able to evolve. Organically, they do not rise above tissues which, in the higher vegetables, are formed in the embryonic sac of the ovary, and precede the germinative development of the new individual. They might be called the abortive children of the vegetable world. Their different species are like so many blind alleys, as if, by renouncing the mode of alimentation customary amongst vegetables, they had been brought to a standstill on the highway of vegetable evolution. As to the Drosera, the Dionaea, and insectivorous plants in general, they are fed by their roots. Like other plants, they too fix, by their green parts, the carbon of the carbonic acid in the atmosphere. Their faculty of capturing, absorbing, and digesting insects must have arisen late, in quite exceptional cases where the soil was too poor to furnish sufficient nourishment. In a general way, then, if we attach less importance to the pressure of special characters than to their tendency to develop, and if we regard as essential that tendency along which evolution has been able to continue indefinitely, we may say that vegetables are distinguished from animals by their power of creating organic matter out of mineral elements which they draw directly from the air and earth and water. But now we come to another difference, deeper than this, though not unconnected with it. The animal, being unable to fix directly the carbon and nitrogen which are everywhere to be found, has to seek for its nourishment vegetables which have already fixed these elements, or animals which have taken them from the vegetable kingdom. So the animal must be able to move. From the amoeba, which thrusts out its pseudopodia at random to seize the organic matter scattered in a drop of water, up to the higher animals which have sense organs with which to recognize their prey, locomotor organs to go and seize it, and a nervous system to coordinate their movements with their sensations. Animal life is characterized in its general direction by mobility in space. In its most rudimentary form, the animal is a tiny mass of protoplasm enveloped at most in a thin, albuminous pellicle, which allows full freedom for change of shape and movement. The vegetable cell, on the contrary, is surrounded by a membrane of cellulose, which condemns it to immobility, and, from the bottom to the top of the vegetable kingdom, there are the same habits growing more and more sedentary, the plant having no need to move, and finding around it, in the air and water and soil in which it is placed, the mineral elements it can appropriate directly. It is true that phenomena of movement are seen in plants. Darwin has written a well-known work on the movements of climbing plants. He studied also the contrivances of certain insectivorous plants, such as the Drosera and the Dionaea, to seize their prey. The leaf movements of the acacia, the sensitive plant, etc., are well known. Moreover, the circulation of the vegetable protoplasm within its sheath bears witness to its relationship to the protoplasm of animals. whilst in a large number of animal species, generally parasites, phenomena of fixation, analogous to those vegetables, can be observed. Here again, it would be a mistake to claim that fixity and mobility are the two characters which enable us to decide, by simple inspection alone, whether we have before us a plant or an animal. But fixity in the animal generally seems like a torpor into which the species has fallen, a refusal to evolve further in a certain direction. It is closely akin to parasitism, and is accompanied by features that recall those of vegetable life. On the other hand, the movements of vegetables have neither the frequency nor the variety of those of animals. Generally they involve only part of the organism and scarcely ever extend to the whole. In the exceptional cases in which a vague spontaneity appears in vegetables, it is as if we beheld the accidental awakening of an activity normally asleep. In short, although both mobility and fixity exist in the vegetable as in the animal world, the balance is clearly in favor of fixity in the one case and of mobility in the other. These two opposite tendencies are so plainly directive of the two evolutions that the two kingdoms might almost be defined by them, but fixity and mobility, again, are only superficial signs of tendencies that are still deeper. Between mobility and consciousness there is an obvious relationship. No doubt the consciousness of the higher organisms seems bound up with certain cerebral arrangements. The more the nervous system develops, the more numerous and more precise become the movements among which it can choose. The clearer also The clearer also is the consciousness that accompanies them. But neither this mobility nor this choice, nor consequently this consciousness, involves as a necessary condition the presence of a nervous system. The latter has only canalized in definite directions, and brought up to a higher degree of intensity a rudimentary and vague activity, diffused throughout the mass of the organized substance. The lower we descend in the animal species, the more the nervous centers are simplified, and the more, too, they separate from each other, till finally the nervous elements disappear, merged in the mass of a less differentiated organism. But it is the same with all the other apparatus, with all the other anatomical elements, and it would be absurd to refuse consciousness to an animal because it has no brain, as to declare it incapable of nourishing itself because it has no stomach. The truth is that the nervous system arises, like the other systems, from a division of labor. It does not create the function, it only brings it to a higher degree of intensity and precision by giving it the double form of reflex and voluntary activity. To accomplish a true reflex movement, a whole mechanism is necessary, set up in the spinal cord or the medulla. To choose voluntarily between several definite courses of action, cerebral centers are necessary, that is, crossways from which paths start, leading to motor mechanisms of diverse form but equal precision. But where nervous elements are not yet canalized, still less concentrated into a system, there is something from which, by a kind of splitting, both the reflex and the voluntary will arise, something which has neither the mechanical precision of the former nor the intelligent hesitations of the latter, but which, partaking of both, it may be infinitesimally a reaction simply undecided, and therefore vaguely conscious. This amounts to saying that the humblest organism is conscious in proportion to its power to move freely. Is consciousness here in relation to movement the effect or the cause? In one sense it is the cause, since it has to direct locomotion. But in another sense it is the effect, for it is the motor activity that maintains it, and once this activity disappears, consciousness dies away or rather falls asleep. In crustaceans such as the Rhizocephala, which must formerly have shown a more differentiated fixity and parasitism accompany the degeneration and almost complete disappearance of the nervous system. Since in this case the progress of organization must have localized all the conscious activity in nervous centers, we may conjecture that consciousness is even weaker in animals of this kind than in organisms much less differentiated, which have never had nervous centers but have remained mobile. How then could the plant, which is fixed in the earth and finds its food on the spot, have developed in the direction of conscious activity? The membrane of cellulose, in which the protoplasm wraps itself up, not only prevents the simplest vegetable organism from moving, but screens it also, in some measure, from those outer stimuli which act on the sensibility of the animal as irritants and prevent it from going to sleep. The plant is therefore unconscious. Here again, however, we must beware of radical distinctions. Unconscious and conscious are not two labels which can be mechanically fastened, the one of every vegetable cell, the other on all animals. While consciousness sleeps in the animal which has degenerated into a motionless parasite, it probably awakens in the vegetable that has regained liberty of movement, and awakens in just the degree to which the vegetable has reconquered this liberty. Nevertheless, consciousness and unconsciousness mark the directions in which the two kingdoms have developed, in the sense that to find the best specimens of consciousness in the animal, we must ascend to the highest representatives of the series, whereas to find probable causes of vegetable consciousness, we must descend as low as possible in the scale of plants, down to the zoospores and the algae, for instance, and more generally to those unicellular organisms which may be said to hesitate between the vegetable form and animality. From this standpoint and in this measure, we should define the animal by sensibility and awakened consciousness, the vegetable by consciousness, asleep, and by insensibility. To sum up, the vegetable manufactures organic substances directly with mineral substances. As a rule, this aptitude enables it to dispense with movement and so with feeling. Animals, which are obliged to go in search of their food, have evolved in the direction of locomotor activity, and consequently of a more conspicuous, more and consequently of a consciousness more and more distinct, more and more ample.